Well, it's good. So let me see, I'm trying to admit everybody at the same time. So the good news is the stuff that we're starting right now is stuff that you will need and will be using in CS300. It's like, it ties in. So CS300 is in a different programming language. It's in C, but this is going to be something that you will be using in CS300. So it's very important. The other thing, I'm really, really excited, and it's like, I love this topic. It's like one of my favorite topics in CS. Actually, we teach in CS250, but it's the notion. It's this notion of you hear them referred to as pointers. Okay, and so I know it's weird on a Friday before spring break to start a new topic, but this is one of those where you kind of want to introduce it and then refresh it again because it is so important. Okay. So in a lot of ways, this is actually perfect. Okay. If you're looking at Zybooks, this is, oh, I looked it up and now I forgot. I think it was chapter 8 on Zybooks. Let me have a quick check. I think it's just called pointers too. Yeah, it is just called pointers. So chapter 8 on Zybooks. I'm going to write it down so you have it on there. Okay. So yep, chapter 8 on Zybooks. If you like going through the examples. Okay. All right. So the whole idea behind pointers is we're sort of getting lower level and closer to the actual computer and how it stores things. Okay, so we've sort of, it seems like we're actually like right there writing in this weird strange language, this C++, but we've also been extracted out because we've been using, I'm going to step back a bit, or maybe I'll do it here, but we've been doing these things with variables, right? And so what we've been saying is, okay, we know that inside of int main, I can create a variable, say for example, X, and I can create, I'm going to create a few different ones. I can create an array. So maybe I'll create an array of doubles, a nums, 5. And let's say we can create, yes, it's been recorded, Kaylina. I can create a rational called C rational and give it a number. Okay. All right. So, and we've really, whenever I've done anything like this, I've always kind of taken a step back and said, remember, this is stored in memory somehow. Okay. And memory, there's two kinds of different storage, right? In memory, there's working memory, which is the one that's running, the one that you have access to while a program is running, versus storage, which is when you shut down your computer and you save your like music files and your text documents, right? Those are permanent, right? Versus the memory that we're talking about is what we, if you buy a computer, it's what they call RAM, right? It's the working memory. It's how much you can have, how much memory you have in place as something is running, right? And so, when I, write a program, okay, let me try and do this. So if I write a program, let's call this program test.cpp, right? So when I do test.cpp, that's my file, right? It's going to go through something called a compiler, right? Or a build. In that case, they call it a builder too, but it's going to go through a compiler, so called a build, right? And actually what that does is it produces, and you've seen these before, right? It produces these OBJ files, right? Right. So actually compile. So build does a couple of things. I'm just going to step back a little bit. So the compiler pulls in something called makes something called a test.obj. Then there's this other thing called a linker, which will then produce a test.exe or your executable program. Okay, and that's a lot of times whenever you see an executable, you double click it, that runs, right? Anytime you like, I don't know, download an app for your phone, it's some sort of executable, right? Or you download like Visual Studio, there's an executable there that starts a program. Now, of course, Windows and Mac, they hide a lot of that from us. We just kind of double click something and it works, but that's what it is. It's an executable underneath. Both of these terms together is called building in Visual Studio. Visual Studio kind of does something nice where it kind of combines all that together. Okay, it combines the compiler and the linker to produce the executable. Now, the linker will do things like link together multiple projects, and you've already got a taste of that, right? When you create your rational class and your rational set class, we link those two. What you end up with is a rational.obj, which stands for object, but you have your rational.obj and your rational set.obj. Those get linked together, produce an executable, and that's what runs. Okay. Now, the next step is, once you've got your executable, that's when you hit, what do they call it? Debug in Visual Studio, or you run the program. So we run the program, and in Visual Studio, they call it debug or debug. What is it called again? Start without debugging, right? That's what it is. Start. All these IDEs have slightly different names, but start without debugging, right? And that will run your program and execute your code. And when I mean execute your code, you started looking through the debugger now. It basically means I'm going to start at main and I'm going to start running this code. Okay. And every time I run that program, it will go through the main and start allocating memory. Okay. So that is sort of your process. And then when it starts running, I'm going to do another line here, then you start having the memory. And now memory, if you do more CS and you take, there's another course called operating system, you learn a lot more about memory. But from a programmer point of view, what we do with memory is we allocate enough space based on the type of object that we have, or the type of variable that we have, right? So for X, for example, is an integer, right? And I believe on most of these systems, an integer is the size of 4 bytes. Okay, depends on the system sometimes and the way you build your program. Okay, a double is another one. So a nums, in this case, it's an array, so it's going to actually allocate 5 doubles, right? Even though they look smaller, each one of these is going to have a specific size, and in the case of doubles, those are 8 bytes. And just occurred to me, do you know what a byte is? Probably. I'm not using this terminology. I do get pretty excited. So let me talk about the sidetrack a little bit, just so you know. Okay, here's the magic, all right? The magic here is that at the end of the day, when you're looking at these computers, these boxes, your phones or whatever, all we've got inside is just electronic circuits, right? And each of those is composed of bits, which is a 0 or a 1. And if you just if you just take 5 minutes and just trying to think about how we've gone from like having these on-off switches, and if you look at computers from like 100 years ago, maybe not 100, we haven't had computers 100 years, 80 years ago. But if you look at those computers from there, that's all they were, with these on-off switches, right? It's just now we have, millions of them together, billions of them together, right? And so those on-off switches are called bits, right? So a 1 bit is an on-off switch, right? So it can have 2 states. It can either be on or off, which is your 0 or 1, right? And then what we start thinking is, as we start realizing, okay, the only thing you can store with 1 bit is as a Boolean. It's like it can only be true or false, right? When we start doing, growing what we can do, right? Then you get 8 bits, which is equivalent to 1 byte. So that's what it is. So whenever I talk about a byte, I'm talking about 8 bits. So what that means is with one, what that means is I can represent 0. I'll do all zeros, but I can represent something like this, right? Or I could represent something like this, right? And what are the possibilities? How many possible things could you represent with 8 bytes? With 1 bit, you can represent 2 things. So in the private chat, tell me how many we could represent with 1 byte. So 1 bit represents 2 things. So with 1 byte, I'll do it. With 1 byte, we can represent how many things? Just tell me what you think. Yep. Good guesses. Okay, so Trent's got it, Corey's got it, Ashley, Casper, Joe, Daisy, not quite. Caden's got it. Not quite, Casper. So think about it. Think of all the possibilities. I mean, you can do it mathematically, but I'm just gonna, like, this is another possibility, right? Another one is 11000110, right? I mean, I can go on. There's so many. Question is how many? Joe, Daisy, where do you get those numbers? I'm just curious. You can type it in the chat. Same with you, Jordan. You all came up with the same number. I'm just curious where you all came up with that number. So Joe, Daisy, Jordan. Oh, I see. Okay. Nice job, Ashley. That's a big number, Taylor. I don't think it's quite right. It says how many possibilities? Yeah, so how many possibilities are there with 8 bits or 1 byte? Yeah, so you got it. Yeah, that's fine. So do it the other way around. So both Daisy, Joe, and Jordan, you do it the other way around. Okay, there you go. Very good. Okay, so the question is, so with 1 byte, we can represent blank different thing. I'll just call it different things, right? There's different possibility. And what it is, if you think about it with 1 bit, actually, let's take a step back before I just give you the answer. I'm going to bring this down a bit. So give myself some space. With 1 bit, I can represent 2 things. With 2 bits, how many things can I represent? How many separate items can I represent? There you go, George and Joe, Sarah, very good. So with 2 bits, I could represent 0, 0, 0, 1, 1, 0, 1, 1, right? So with 2 bits, I've got 4 possibilities, right? With 1 bit, I have 2 possibilities. Or 2 things. Should do things, stick with the same terminology. Okay. With 3 bits, so if we expand it a little bit, with 3 bits, I've got 0, 0, 0. Space. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So how many do I have here? I have 8. Okay. Yep. So 8. And so so if you extrapolate that out, you end up with saying, okay, 2 with 1 bit, I can represent 2 to the 1 things. Okay, because 2 to the 1 is 2. With 2 bits, I can represent 4 things. With 3 bits, I can represent 8 things, which is 2 to the 3rd, right? And so with 8 bits, I can represent 2 to the 8, which is 256 things, right? And so with X bits, right? Oops, yeah, with X bits, so 1 byte is 8 bits, right? So with X bits, we can represent 2 to the X different things, okay? And I can't spell, but anyway, to the 8th different things, okay? So so these are the reasons, okay, when you think about, if we're going down, if we, you know, we think int, double, char, whatever, right? But if we go right down into the kind of the bits, we realize that those aren't just randomly sized, they're sized because of what they can possibly represent, right? So if I can represent 200 or 2 to the 8 items with 8 bits, right, then 1 byte can represent 256 things, right? So if I'm going to step back a bit, so if I have 4 bytes, right, then you've got 2 to the 32, right? So with an integer, I could represent 2 to the 32 possibilities if it was 4 bytes. With 8 bytes, I've got 2 to the 64 possible numbers that I can store just within that 8 bytes. So that's what I mean by 8 bytes. So stepping back a little bit, enums, each one of these is 8 bytes long, which means I can store a double inside of here, okay? Okay. Yeah, we can talk about quantum computers, but that's like a whole different things. They're also bits, but they're bits that fluctuate between on and off. That's what quantum computers are, instead of our stable bits, which are either on or they're off, right? Anyway, so going back, okay, stepping back. So now we know a little bit about bits and bytes. We now know that whenever we create a variable, we're basically taking space and memory and allocating space to store something. And it depends on the size. And so, for example, rational, a CRAT, we know in memory is going to hold two different things. And I'm going to do it a little bit differently, because if we think about memory as sort of this kind of chunk of organized data. But yeah, so if we think about CRAT, it's going to have whatever, an M numerator and an M denominator. And each of these, I believe, were integers. So each of these would be 4 bytes, right? Because it represents an integer. Right. And so when you look at it this way, you can kind of see, oh, yeah, okay. So array that has 5 items, each item is 8 bytes. That is huge. That's taking a bigger chunk of memory than, say, a C rational, right? A C rational just has 2 integers in it. A C rat is a little bit different because it also has functions, but we'll just ignore that for now. Okay, abstract that out. Okay, so the other thing we've abstracted out is how to then access that, right? So one thing we can do is, all right, I can then go ahead and say X gets 70, okay? And we know then that I can store a 70 in here. Now, what's stored actually inside of the device is a sequence of zeros and ones that represent 70, right? There's a sequence of zeros and ones representing 70. But we sort of abstract all that out and say we're storing 70, okay? Now, all right, now, again, before I kind of get into pointers, we haven't even got to the pointers yet. We're just kind of figuring out how memory works. One of the limitations that we have right now, right, is going back to this picture here, is that once I write this code, right, and I create the executable, right, I build it and I create this executable, whenever I run it, whatever memory I've created is fixed. It doesn't matter, even if I only have 1 double, I'm allocating 5. Or maybe I'll make it 500, right? Just thinking about this array. This array has been a problem. This fixed size array has been a problem since you started programming, right, in CS 150. And the reason it's been a problem is because I have to guess or estimate how much space the user needs. Oh, do you have 100 students? Okay, I'll make the max size 100. Oh, but what now if you have 200 students, right? I have to kind of go back in and edit and rebuild the executable, which usually means, if you think about it like as a real app, that means you have to push update to the user, right? They have to then update their software, okay? And so that's not great. And so, so what we want to be able to do is not have everything be fixed, but to be dynamic, right? So this is all like fixed, static. And what we want to do is have something be dynamic. So in other words, when a program runs, I'll allocate memory. It's like, oh, I need to allocate more memory now for something, okay? And so that's what we call dynamic memory, is we're going to start allocating memory on the fly as we need it, okay? Okay, one more thing before I kind of begin talking about pointers is just thinking about programming languages, because I know you've had exposure to other languages. Pointers, so the C and C++, okay, both of those use pointers, okay? And when you use pointers, it's really cool because you're getting into the details of the code, but you also have to be, it's also very dangerous, because if you allocate memory and don't delete it, you get those memory leaks. So if you've ever seen a program, it doesn't happen so much anymore because programming languages have gotten smarter, but they used to run out of space, run out of memory. You have something running and then suddenly it runs out of memory and crashes, okay? And that's because they didn't delete memory as they allocated. But these ones do use pointers. If you've used Java or Python, they do not use pointers, okay? So the concept of a pointer is not used in these programming languages. Internally they do, but they've abstracted it out, right? So that when you're coding in Python or Java, you never have to worry about pointers. Okay. The other benefit, so you're like, okay, so why do we do it? It's like, okay, it's kind of cool to get into the memory and do things, but if it can cause issues, why don't we just do this, right? Do Java, Python, and not use pointers. The benefit of pointers and why it's never going to stop, never going to go away, is they speed up programs. So they speed up running programs. So what do I mean by that? Because these programs still use pointers, but it means that it slows it down because you have to kind of go through a library to get to those pointers to use them. And so they kind of run slow. And so what you'll find is actually when you go into like big software development, you may be developing in Java, but there's going to be some library that you're using that your colleague in the room next door is actually developing in C, because that makes it run fast, right? It makes it run faster on the device. And so anytime you've got speed is an issue, like time you're thinking about video games, all that kind of thing, you might be kind of on the interface kind of doing in Java and Python, but there's also going to be these C components to speed things up. Okay. Pointers are like, there's no CS person who does not know pointers. You have to learn pointers. It comes up in job interviews, and it's just a very standard thing. Okay. All right. So I think that's all I want to do in terms of motivation and talking about them. So questions.
What does a pointer look like? Is it something like we denote? Like, how do we use it? Do we use a library, or I mean, you just
Yep.
said,
Yeah, no, it's good. A good question, right? Now you're curious. Okay, now I know what they are. How do we use them? So that's what we're going to do. It's going to be, okay, it's going to be annoying because we don't need a library, but it's just going to be using symbols we already use for other things. I'll just write them here. So we're going to be using an asterisk, and we're going to be using an ampersand again. And that's how we use pointers. There's no actual like name or anything else. So it's like, you're like, oh God, it's taken, you know, I always, it's funny because I always say mathematicians do this, right? Where they take symbols and use different symbols to mean the same thing, depending on the math class or whatever, right? But then, you know, if I really look into CS, we kind of do the same thing, okay? Because we use the star for multiply, we use the star for, we use the ampersand for pass by reference, we use the ampersand for and. So yeah, I think we just run out of symbols. Yeah, so good question. So Taylor asked a question, are there software that allow multiple languages to work together to form one executable? Absolutely. Actually, they all do. Okay. Most big things that you use, any big software that you use, it's very rarely written in just one language anymore. Okay. They always have components. Sometimes they're just using libraries that were written in a different language. But you see this linker, I've really kind of hidden away a lot of the details, but this linker is going to actually link like something up here, something down here, something down here that might all be different languages, and they produce one executable, right? But they kind of plug all these components, and there's a linker that will link all those together. Okay. The different languages, like here, this is C++. That's why it's called a CPP file, right? A Java would be a jar file. Actually, what is a Java file? I haven't done Java in so long. Python is PY. I think it's just .java, isn't it? I think it's just .java, right? But anyway, what they do is with their compilers, there's a lot of differences, but they will produce some sort of object file, and those can be linked together. Okay. Okay, other questions? All right, let's get into pointers. This is fun stuff. All right, so what is a pointer? At the end of all this, right? It's like we haven't even talked about what is a pointer. So a pointer is really just the address of a variable, okay? So if you think about, I'm going to simplify again. I'll just use integers for now, okay? So if you think about main, and I create an int x, y, z, okay? That's all I've got. Then inside of memory, okay? Memory actually is a sequence we're kind of like an array in some ways, but you kind of visualize it as a sequence of slots, okay? And they generally are, most memory is a byte addressed, so it's addressed by byte, okay? So inside a memory, we've basically got, it really is kind of like an array, but these are all bytes, right? So I have a byte, they're 1 byte. The size of each of these are byte, they're always byte addressable, okay? And then what we do, oh, and they each have an address, okay? So they each have an address and it's 1 byte long. So this might be, and I'm just gonna, the address are in hexadecimal. I'm not even gonna go there now. I'm just gonna say, let's assume there's usually a bunch of addresses that are used for operating system and stuff like that. So let's just start at address 1000, okay? Because we're assuming this memory that's being used for something else. Then this is gonna be addressed 1001. This one's gonna be addressed as 1002. This one's gonna be 1003, and so on, okay? It's just, and it's in sequence just like this, okay? This is stat memory, okay? And then what happens is your compiler comes along and it says, we've got a variable named X. Oh, and it says, oh, X is an integer. So it's like, okay, I know an integer is 4 bytes. So I'm gonna allocate, I'm gonna take these 4 bytes and I'm gonna use that to store my X variable, okay? Then it says, oh, we have a Y. So it's going to say, okay, I'm going to take 4, the next 4, and that's going to be used to store the Y. Okay, because I need 4 bytes. And so on, and it allocates memory that way. Okay. So when I say, going back to my definition, when I say a pointer is the memory address of the variable, what it means is that the variable, the pointer, is going to hold an address. I'm going to very roughly draw it here, and then we'll draw it again on the other side. But it will very roughly here, I will have something that says I'm going to store, say, 1004. And so what it is it's holding the address of another variable, or what we call it a pointer, is it's pointing to another variable. Okay, so a pointer, when it says it's the memory address of a variable, basically means that it's space in memory. It's a variable, still a variable, but all it can hold, instead of holding data or a value, it holds an address, a memory address. Okay, so it points to another variable. And it seems like a weird level of abstraction, but if you bear with me, you'll see it will come into play when we do dynamic memory, okay? Which may not happen today, depending on time. So, so let's have a look at another example, right, that I have here, all right? And I'm going to kind of walk you through the terminology a little bit. So here, by the way, one thing I didn't actually mention before, a char, a character, is 1 byte. Okay, so we only have 8 bits, so 1 byte is the size of it. We use chars a lot when we talk about pointers because it's simple, because it's 1 byte instead of like 4 for an integer. Okay, so char just takes 1 byte, stores 1 byte. I'm going to start with the simple form. So here I've got a ch, which is a character, which is a variable of type char. Okay. And so that goes into memory. So if we think about here's the memory, there's that ch. I've allocated space for that ch. Okay. Now the pointer here, and I'm just going to double check one thing. I need to make sure that my pointer size, I don't give you the incorrect information about the size of a pointer. So I believe, oops. I believe a pointer is 4 bytes, but I want to double check before I tell you that. Yeah, 4 bytes. A pointer is 4 bytes. Just want to double check that fact. Okay, so a char is 1 byte. I'm going to write that down. It doesn't matter what kind of pointer it is, but a pointer is always 4 bytes. Okay, that's how much space it takes when you allocate. All right. Now, the way that we create a pointer is we do this star. All right. This statement, it's weird because it can look confusing. It can be, you can think of it as 2 separate statements, where here I'm creating a pointer to a char. So the way to read this is I have created a variable named PCH, and the type of this variable is a pointer to a char. Okay. And then I can create that second variable is the char, and that's just a simple char, a simple CH. Okay, so the only difference between these two right now, I mean, other than the variable names, but the only difference between these two right now is that star. And because I have a star here, that means I have a pointer. So PCH doesn't actually store a character. It stores an address, a memory address to a character. Okay, so let's assume that PCH will stick with 1000. Okay, and we don't have a value right now. So at this point where I create these, right, there's no values. I haven't done PCH gets a value or CH gets a value. Okay, so I have PCH, the address is 1000. So if I put CH down here, what address, here's the question, what address, or what should I write here? What address would CH have? Put it in the direct chat based on everything I've said. So again, the question is, what should I put in this box here? Or what is the address of CH? Okay, thank you, Trent. Thank you, Ashley. Thanks, Jordan. Thanks, Casper. Thanks, Joe. So far, nobody's got it yet. Okay. Just so you know. And by address here, remember, there's two different things. The address is the location of this variable, and the value is going to be what's stored inside of it, right? So the memory address, this refers to the location of the variable. Yeah, nobody's got it yet. And the value is what is stored inside the variable. So you're all guessing 1000. A lot of people are guessing 1000, and that's not correct. Like most people have guessed 1000. So think about it this way. I'm going to go back to the previous slide and we'll come back here. So if you look over here, when I say the address, I mean this thing here, right? The address, right? So here, X had an address of 1000, right? And it didn't have a value yet because we haven't assigned anything. Y has an address of 1004, right? Because we know we've talked about, so I have int. Actually, I think some people did get it right. Sorry, yeah. So James did get it right. I'm sorry, Jordan, I think did get it right. And no, not Jordan. Sorry, Trent and Ashley did get it right. Maximus did get it right, and James got it right. Not quite, Trent. So think about so the other thing we need to think about, I'll write these down. So I've already written here, a char is 1 byte, a pointer is 4 bytes, an int is 4 bytes. Okay, and I could have also, a double is 8 bytes, right? So they're all different sizes. And so since I know, actually, you might be wrong. I'm sorry, I'm thinking, I forget which order they're in. So actually the ones yeah, I'm just gonna give you the answer. So if PCH is a pointer, okay, so how much space does it occupy? Well, a pointer is 4 bytes. So this PCH is going to take the spots 1000, 1001, 1002, 1003, right? And so, because it's going to take 4 bytes. And so CH is going to start at the one below it, or the next one, which would be 1004. Okay. Right. I'll draw it sort of similar to what I had over there. It's just a different representation of the same thing, right? So if memory, again, byte addressable. So that means that we address it by bytes, like each one of these boxes represents 1 byte. So we have 1000, 1001, 1002, 1003, 1004. I'm just going to stop right there. Okay. And I'll do the same thing as I did before. So PCH is a pointer to a char. And because it's a pointer has 4 bytes. Then I'm going to allocate 4 bytes, 1, 2, 3, 4, right? And this is going to be my PCH. That's representing my PCH. The next one, the character, is 1 byte. The char is only 1 byte. Let's do the CH is going to be in a different color. And so this is going to be my CH, right? And so that's going to take that spot over there. Then if I created another thing like an integer, it's going to start at the next one, which would be 1005. Okay. So that's what I mean here by what is the memory address or the location of the variable. All right. So at this point, right, we've allocated space for a pointer to a character and to a character. Okay, and there they are in memory, and there they are in kind of different representation of memory. Okay. Now let's look at some other things. Okay, so so this star here created a pointer to a char. Okay, it declared a variable, allocated space for a pointer to a char. Now we have this ampersand, and this ampersand means address of. That's how you interpret that ampersand, it means the address of. So if I'm reading this statement, then what I'm saying is PCH gets the address of the variable named CH. Okay, so I'll try it again. So PCH gets the address of CH. And instead of gets, you could use assigned, right? So PCH is assigned the address of CH. Okay, so if I take this statement, try and do it in different color. I'm hoping different colors help things along somehow. Let's try this color. Okay, so once I do this statement here, I execute this statement, then what it's going to do is it's going to come into my table here and say PCH is assigned. So inside of the value, it's going to be assigned the address of CH. Well, what's the address of CH? It's 1004. Okay, so I'll try and do it again. So PCH, there it is. There's PCH. PCH is assigned. So the value that's going to get stored in there is the address of CH. The address of CH is 1004. So that's what I'm going to do there. Okay. The other way to think about it, I'm just going to show you different ways of representing this. Okay. So the other way to represent it is to say, what is it? That PCH, which we know it down here is taken up this 4 bytes, is going to store the address of CH. So in other words, PCH is going to be, we're going to store 1004 because that's the address of PCH. And the way we can even draw it is draw it as a pointer, as an arrow. So what we can look at it visually, we can say that PCH points to CH, contains the address of CH, it points to CH. That's where the word pointer comes from. Okay. Okay, any questions on this part? Okay, so let's do the next bit. Let's do this one in green. I don't know. So this next statement, okay, again, is kind of a strange one. We're using the star again, and we're using the star again in a slightly different context. This thing here is called dereferencing the pointer. Okay, what it means is, let's do it this way. If I didn't have that star there, then I say PCH gets A, then it will try to put the character A inside of the variable PCH. Okay, but we're saying that's not what we're trying to do. What we're trying to do is dereference or follow the arrow or go to wherever PCH is pointing to and assign it the value A. Okay, so let's kind of go over here. So even though PCH is getting the value, it's not PCH directly that's getting the value. It's whatever PCH is pointing to, or the address, or whatever. So PCH contains this address. I follow that address, and I'm like, oh, there it is. CH, it's actually pointing to CH, and so CH is the one that's going to get A stored in there. Okay. Can do it again one more time below. We're going to follow the arrow. So when I say PCH, when I dereference PCH, when I say star PCH, that means follow the arrow, right? So what is PCH pointing to? That's what I'm assigning that value to. Okay. Okay. So that is, you know, the top level, highest level introduction to pointers. We've got to do the output. So that's not something I've done yet. So so I just want to finish off this program here. So we've got the output. We're going to do a couple things. We're doing three things in the output. The first is if you ran this and you just do size of PCH is, and you do the space, there's this nice little function that's built into C++ called size of. And what that will do is it will print out like the size in bytes. So I think it will, so in this case, it will say 4. I don't remember if it says 4 bytes or 4, but it will say 4. I think it just says 4. And then this one here will say, the next one, sorry, will say size of CH is 1. And that is just kind of to verify that you know that it's going to be, that the PCH is 4 bytes and the CH is 1 byte. And then the last part here is straightforward. So cout CH is going to output A. It's just, again, verifying that A was stored in CH, and then space. And then we're going to output star PCH. Well, what do you think that's going to output? So there's my next question for you, because I need a drink. What is output here? What is the output by this statement? So here. So I've done all these couts, and I've just got to this part here. So everybody have a go in the chat while I get a bit of a drink. I'm getting lots of different outputs. I'll give you a little hint. The star PCH, it's the same as this star PCH. So what is this star doing? Okay, nice job, Portia. Nice job, Ashley. Allie, nice job. Sarah, Jordan, Kaden, James. Good. Yep. So once you see, okay, so once you see that what we're doing is following the arrow, so whatever PCH is pointing to, then, so we're dereferencing the pointer, we're following the arrow, then that's equivalent to saying, in this case, cout CH, because star PCH, in this case, is, or PCH is pointing to CH. So the star PCH is equivalent to CH. So all we're doing is we're following the arrow, or in the case of this table, if you're looking at this table, we're looking at what is the value stored here. Oh, it's 1004. I'm going to output whatever stored at address 1004. So it will just output A. It's just another way of outputting A. And that's it. It's not going to output the 1004 or any other kind of number, because this is, remember, this part is just the address. That's just for our help, right? The actual value stored in PCH is 1004, and the actual value stored in CH is A, right? These addresses are not, like, those are just where they're stored in memory. Okay. Okay, questions? And then otherwise I'm going to walk you through, I think, some one by one. How would I access the address if I wanted to somehow print it? So Ashley's asking, good question, how would I print out the address? So if I wanted to print PCH, how would I print that out? How would I print out its value, which is 1004? You could, if you want to, by doing cout PCH, it's capital C, PCH, and that will store whatever is stored in PCH, which is going to be an address. But when you do, and you can try this, and I recommend that you try this. When you do run that, it will output a hex value, a hexadecimal value, which is, it's going to, I think it will be in the form 0x to represent hexadecimal, and then it will be a mix of numbers and then letters A through F. That's how we store hexadecimals. Okay, so it'll be some number. It won't be as nice or as simple as like 1000 or 1004. It's going to be some weird address. Okay. Other questions? Okay, just gonna have a look. I think oh, it's, you know what? It crashed earlier too on me. I'm not sure why it's doing that. It's like if I scroll too fast or something, it's crashing on me. Don't know if it saved all my notes. I even know where it is actually. I've lost it. It should be 11, I think. It was 11 pointers. Let's see. There it is. Okay, it saved it. I just know where what it's done with it. Okay, another question. Could we convert the hexadecimal somehow to bits bytes? Sure, if you want to. There's online converters that you can use to do that, to convert from hexadecimal to decimal, that kind of thing. We don't usually worry about, I mean, yeah, we don't get down to that level, because then you start getting into, there's another lower level of programming called assembly language programming, and right, you're starting to get into that level of programming. But you certainly could if you wanted to. Okay. All right. So just kind of stepping back now, and actually, let me see. I don't know if I want to do all this introduction. Okay, maybe I do. Okay, so this is kind of just, even though it repeats a lot of what I did, it sort of goes and does it in detail. Okay, so let's kind of walk through it. So length is, or if we look at a statement like this, what we're doing here is we're, if you think about memory, right, we are creating something, a variable named length. And if I do it in my old fashioned way, right, I'll do it like this. And I'm creating a variable named p length, which is that value here. Okay. And with all these boxes that I draw, I'm just kind of like having a visual representation, trying to understand how this information is stored. The difference between p length and length is that the p length has a star next to it, which means it's a pointer. So p length doesn't actually store an integer, it stores an address of an integer. Okay. The p, by the way, is just part of our coding standards. It's so that when I'm looking through the code later on, I know that this variable holds an address. It's a pointer and not just an address. Okay. So that's how we declare a pointer. We use the address of operator to attach the address of operator to any variable to get the address of it, right? So if you remember, p length was a pointer to an integer. And so we're saying that p length contains or is assigned the address of the variable named length, or the memory address of the variable named length. Okay. Something to remember. Yeah, I always forget this. I mean, I guess I just never think about it, but it does come up. So make sure that you never, so the address of operator can never be applied to a constant. Okay, so and it's a reason, because constants are special. They're not variables, they're stored in a different place in memory. Okay, so if I look over here, what do I have? Here I have a pointer to an integer, or a variable that holds a pointer to an integer. Here I have an integer that stores the value 5. Okay. And actually, I'm going to show you how I would draw these, since these have values. So I have a pointer, a px, which right now contains nothing. And I have an x, which has been assigned the value 5, right? I also have this constant integer num, okay? And I'm going to throw num all the way over here, because num is in a special place in memory. It's a constant that has 98, okay? So then this statement over here, when I say px gets the address of x, that means that px is pointing to x. And I like to draw it like this arrow. If you really want to, and that's fine. If it helps you, you can think about this as being the address 1000. And so inside of here, I'm storing the address 1000, right? Because all px is an address, contains the address of a variable. But arrows, to me, visually, like in my head, I can see them better. Okay. But if you try to say that px contains the address of num, or is pointing to num, you're going to get an error. So that is not allowed. Okay. And the same is true if you try to say that px is pointing to the address of like a constant literal named 8, or an integer literal named 8, because it's going to be like 8 is not stored anywhere. I don't know what you're talking about. okay? And that's going to give you an error, okay? Okay, so that's the address of operator. Yeah, so again, these are things that we've seen before, but actually it's a good kind of practice to see what the output is. So here I have x and I have px, which is a pointer to an integer. So x is an integer, px is a pointer to an integer, okay? X is assigned the value 8, px is assigned the address of 8, or it points to 8, okay? So then if I wanted to do the output, you tell me what is going to be displayed when I do the output. So in the chat, tell me what these couts will produce. Each one of those couts, what will that produce? Okay. So size is like the size of the variable, the type, right? So I'm going to go back just a slide. I know you're looking at this very quickly, but I just want to show you the size of where we talked about it here, right? So there's the size of. So size of tells me the size of something. So the size of PCH, the pointer, was 4. The size of CH, which is a char, is 1. It just tells you how much memory they each take. Okay, wrong one. There you go. Okay, C. Yeah, Ali, nice job. Okay. James, you're good on the first two. Curious about your second two, but works. Same with Sarah. So Daisy, first two are good. Not sure about your second two. Yep, Casper, correct. Yeah, your first two are good, Daisy. So second two, I need to think about. Okay. Okay. Okay, Ashley, I'm gonna kind of call you out on those second two in a minute. Not quite there. Okay. So Corey, yeah, your first three are correct. The fourth one is not. Okay, Trent, your third one's not correct. I think the first two are. Sure. Yeah, Trent, go for it. I'll say that. Based on your other answer, could be. All right, so when you're given something like this, this is good. So the first one I'm going to kind of go with, so the first one, X is, it's going to output, right? It's going to output X is, and it's going to say 8 because X is 8. I have 8 stored inside of X, right? The next one is going to be size of X. And so it's going to be like, all right, size of X is, and X is, what is X? X is an integer. And so we know that an integer is 4 bytes. So it's going to say 4. Okay. All right. The next part, this is where you need to call me out. Okay. Because the next one says address of X is and address of X is. And it said, you know, all I've done with these is say that PX is pointing to 8. I actually haven't given any addresses up here. Okay. Now, I think most of you went with 1,000 because that's where I started, which is a good guess. But if it's ever on an exam or anything like that, don't try and, you can do two things. You can say, I'm assuming the addresses start at 1,000 and go with it, or call me out on it and say, I don't know, you haven't told us what the address is. Okay. But let's assume that you'd said, okay, X is actually stored at address 1000, right? Then I know that PX is storing 1000. That's what the value of PX is. And so if this part over here is going to say address of X is, and actually the hint is there in that string. So PX, okay, it's going to take whatever value is stored in PX, which we know contains the address of X because we assigned it up there. So that's going to be 1000. And it's going to do the same thing here when I say address of X is, and it's going to do 1000. Okay. So that's the output. So questions on this one? All right, let's do the last slide. This is where I'm going to stop. Okay, so the last thing I wanted to do is just talk about what we call the indirection operator, which is the star. Okay, which is the same operator used to create a pointer, right? To define a pointer, we use it as the indirection operator. And so what it does is it gets the value the pointer points to. So whatever the pointer is pointing to, that's the value that it outputs. We call it dereferencing the pointer. Okay, so you're actually working on whatever it's pointing to, you're not working on the pointer. And so based on the previous information we had, which I think, actually, let's just do this. Okay, it was just int, I'm going to rewrite it, X star PX, and then I said X gets the address, no, X gets 8, sorry, and PX gets the address of X. That's what we said before, right? And then I said, all right, there's X, which contains 8. There's PX and, oh, PX, not K. PX, which points to or contains the address of 8. Okay. And so then when I say the value here, so here it's going to, the output is going to be value PX is pointing, value PX is pointing to is, so what value is it pointing to? And I dereference PX, and that, like I said, says follow the arrow or go to the address that's stored inside of PX. And so, yeah, so correct. So Trent's already had a go. It's actually going to output 8, because what is PX pointing to, right? We follow the arrow, or we dereference the pointer, or we get the value the pointer points to. So the pointer is pointing to this, and so that's what's going to get displayed. Okay. So that in an hour is our pointers. Okay, the basics of pointers. The biggest takeaways that you need to get out of it are these last few slides. I'm going to actually just write it down, just so you know. So we really know how to declare a pointer, right? Which is create a pointer variable, right? So I'm going to put star. So that's how we declare a pointer. We know how to assign a value to a pointer or make the pointer point to something. And that's where we use the address of operator. And then we know how to dereference a pointer. Okay, which we use the indirection operator, which is also a star. Okay, that's what we did. Okay, and your task from now until 10 days from now is to try and remember this. So we can start on Monday working more with pointers. Okay. It's still going to be the same notes. So if you want to look ahead, but we're going to start with this pointer. Okay. But don't worry about it for now. This is where I'm going to stop. We finish a bit early because why not? Because it's a lot of information. The next assignment is going to use pointers. And the next assignment is also going to use operator overloads. They get tied together. Okay, so it's a nice combination. Like I said, I'll try and put the assignment up, probably put the assignment up this weekend. You choose to look at it or not. We assume it's going to be assigned like officially on Monday, but I'm just going to put it up in case you want to have if you have time over spring break and you want to play with code. Okay. All right. Well, I hope you have a wonderful break, well-deserved. It's quite a semester. I'm so glad that Pacific kept spring break. I know other schools have got rid of their spring breaks. So we're very lucky that we still have it. But have fun, take some time to catch up on sleep and relax, and yeah, come back with some fun stories. Yep, you don't need to start anything till after spring break. Not assuming, you don't have to, you know what, you can put CS aside. Just don't forget everything, but just put it aside. All right.
Thank you.
Yeah,
Thank
you're
you.
welcome. Thanks, everybody. Have a great break.
Could I ask a question before class ends? Or-
Yeah. Yeah, and Daisy has a question too, so I'm gonna talk with her. Okay, so go for it, Ashley.
I have a question on the address part when going to
Oh.
slide 8.
Okay, I'm gonna,
and
sorry.
I
It's
thought,
okay. No, I thought it was gonna be on something different, so I'm gonna go back. Okay,
oh, yeah, sorry.
that's all good. All right, so you wanted slide 8. Okay, yep.
I didn't get how you got the last address with address of X is 1000. I got the first one, but I didn't understand it.
This one. So,
Yeah.
so this is the address of operator. Okay. And so what it does is it looks at X and gets the address of it, which is 1000, and that's what's displayed.
Oh, okay.
Yep. It's the same. This is the same thing that we use up here when we assigned the value to PX.
Okay.
Okay.
So PX equals the address of X, which is
Yep.
1000. Okay. Thank
Yep.
you.
Yep. You're welcome.